So the problem is, given two strings S and T, determine if they are isomorphic. So what are isomorphic strings? They have told us two strings S and T are isomorphic if the characters in S can be replaced to get T. What does that mean is, see, this is one string, right? So if we decided to replace E by A, that is here, and replace these G's by D, that G, wherever there is G, we are replacing by D, then what will happen? See, this string will be converted into E replaced by A, G replaced by D, and G is replaced by D. So ADD, and it is equal to what? This T. So that means these two strings are isomorphic strings. But the question is remaining. What they have told, all occurrences of character must be replaced with another character. Means if we replaced G by D, then all the G's should be replaced by D's, right? We cannot replace only one while preserving the order of the characters. Okay, means if this E we have to replace, then we have to replace by the first element of the string only. Why? Because this is at index 0, this is at index 1, this is at index 2. Here in T, this is at index A is at index 0, D is at index 1, and this D is at index 2. So for replacing the element at index 1 in this string, we have to choose the index 1 from another string only. We cannot break this order, right? We have to keep the order of characters in mind. Another thing they have told us, no two characters may map to the same character, but character may map to itself, right? Means if there is a character like A, right, and it is mapped to D, we cannot map A to any other character like E or P something, right? We cannot do that. We can map one character to another, only one character only, one to one. We cannot map one character to multiple characters. But if there are same characters in both the strings, means there are two strings A, B, and another string is that P, B, and we replaced A by P and we replaced B by B, then it is okay. Means a character can map to itself. So we have completed reading our question here. Now the point is, how can we solve this question, right? So as I told you, if this is the case, EGG and ADD, these are the two strings, then what we will do, we will make one hash map, okay, and we will keep the records that E is mapped to A, right? We will run one pointer, right? Now our pointer is here, we will map E to A, okay, that is great. Now we will move our pointer to the next and we will map this G to D, right? Now we will move our pointer, but in our hash map this G is already present here, right? This key we can use simple thing that check whether this G in dictionary or not, right? If it is in dictionary, we can find out that G is already in dictionary, then that means the G is already mapped. So we have to check whether it is mapped to the element or the letter at this index in the another string or not. See, what does that mean is, the G is mapped to D, right? The dictionary of G is equal to D, right? So we have to check whether at this index in the T string, what is the element present? It is D, right? And the G is also mapped to D, so we can easily replace, right? So that we don't have to worry. But if this G is mapped to some other character like let us say Z, and there is D in our second string, then we have to return false. Why? Because we have already mapped G to D, and we cannot map one element to more than two other letters, right? We cannot do this. Are you getting? That's why we have to keep record. Now this example, see, we have an hash map, and what we did, our pointer was on F. So F is in dictionary, no it is not in dictionary, so we mapped F to the first letter in T string. What it is? It is B. Then we moved on O. We checked whether this O in dictionary, no it is not in dictionary, it is not mapped to any element till now, so we can map it to any element now for the first time. So we are mapping it to the A, right? We mapped it. So we moved to the next letter. Now we are on the O. Next letter is also O, but O is already there, so we have to check O is mapped to which element. It is mapped to A, right? But at the third position, or at the second index in this string, there is no A, there is R, right? So the we have to replace this O by R if we have to get this string. See, for getting BAR from FOO, what we have to do? We have to replace F by B, we have to replace O by A, and we have to replace the second O by R, which is not possible because once we map O to any character, we cannot map it to another character, right? We cannot do this. So what will happen? String S will become like this. F will be replaced by B, so it will be B. O will be replaced by A, so it will be A, and this O will also be replaced by A, so it will be like BAA. So this will return false. These strings are not isomorphic. Another thing, imagine if yes is BAR. Imagine if yes is BAR and T is FOO. Okay, we are just altering them, and then check what happens when we try to replace B. When we try to map B to F, it is okay. When we try to map A to O, is okay. When we try to map R to O, is okay. Why? Because we are checking only keys in the dictionary and there is no repeated key, right? So that this will return true, but this will be a wrong answer. Why? Because these are not isomorphic strings, because this O is mapped to A, O is mapped to R, but we are not checking it. That's why this will give us wrong answer. So the point is we have to carry two hash maps, right? See here, we mapped E to A and G to D, and we have to keep another record that map A to E, right? E is mapped to A, likewise A is mapped to E. So this, and likewise G is mapped to D. In similar way, D is also mapped to G, right? So this thing we have to keep in mind, right? We have to check in both the ways. If string S is isomorphic with string T, then string T will also be isomorphic with string S. Okay, this is the property of isomorphic strings, so we have to keep that in mind. So how we will solve this problem programmatically is we will carry two dictionaries and we will carry mapping in that. See, this is the case, right? This is the test case. We will map the first character, right? The first character is E and the first character in this string is A, so we will map the first characters of two strings, E to A, in this dictionary. This is one dictionary, and in another dictionary we will map A to E, right? Just altering. Then we are on the next character G. G is the second letter, so we will map it with second letter of T strings. So G is mapped with D, right? Similar way, D is mapped with G, right? And for when we go to the last element of this string and last element of this string, we will check whether G is already in the dictionary. Yeah, it is already in the dictionary. And what it is mapped to? It is mapped to D. Okay, then what is the third element? See, third element in this string is mapped to D. Then what is the third element in the string? Oh, okay, it is D. only, right? So there is no problem. But if there is something else in this place, then we will return false. See, like here, f is mapped to b, it is completely okay. Now o is mapped to a, it is also completely okay. But when we come to this o is already in the dictionary, right? And the o is mapped to a, that we have recorded in the dictionary, and now o is representing r. So we cannot say that these strings are isomorphic, and we will return false. Okay, now I will explain you the program how can we do that, right? By using two hash maps. So initially what we will do, we will make two dictionaries, right? One we will name yes to t, and another we will name as t to yes. Okay, we will keep records in these dictionaries. What records? The mappings. Okay, and as I told you, we will traverse through each string for index in range len of yes, right? The length of yes and t will be same, that is also told in the problem. See, t dot length is equal to s dot length, so it is a good thing, we don't have to worry about that. Now what we have to do, this is the index for the strings, and yes element will be yes of index, and the element at this same index, that is t element in the string t, will be t of index, right? We are checking for the same index in both the strings, right? If we here we are on f, here we are on b. If we went on o, the second letter, then here also we are on the second letter. If we went on third letter here, then we are on the third letter on the string t, right? So this is how we are traversing. Now we have to check that if this index or this element, which element, yes element, is in the s to t dictionary, means whether it is mapped to any other element in the string t. We have to check yes element in s to t. No, it is not, then okay. If it is, then we have to do something else. I will tell you. And if yes element, if the element in string t is mapped to some element in the string t, then what we have to do, we have to check whether this okay, it is mapped to which element, that we are checking now, whether it is equal to the element in t that is on the same index. And if it is not equal to, then what we have to do, we have to return false, right? If our a is mapped to d in our dictionary, but in the second string, that is string t, there is no d, then what we have to do, we have to return false, because the strings are non isomorphic. So if it is not equal to t of index, or not t of index, it is not equal to t element, right? Then what we have to do, we have to return false. But not only in this case, as I told you, we have two hash maps, right? We are checking whether the element or the letter in this yes string is mapped to any other letter in the string t, and similarly we are checking whether the elements in string t are mapped to string yes. Yes, that we are checking. So how we will check it, we have to put or we have to check that t element in t to s dictionary, whether it is there, and if it is there, to what element it is mapped to. So t to s of t element, whether it is equal to the element, whether it is equal to s element or not. And if it is not equal to, right, if the elements are mismapped, then what we have to do, we have to return false, as I told you. And if this condition is not satisfied, means the yes element is not already mapped to any other element, and the t element is not also already mapped to any other element, then what we have to do, we have to we have to keep this record. Then now we will add, we will map them. If they are not already mapped, then we will map them now. So yes to t of yes element, we will map it to the t element, right? Means element in string yes, we are converting into the string t, right? So we will, like here, we will map this p to t, we will map this a to I, we will map this p, but p is already in the string, and then we will check to what element it is mapped. So we found out that it is mapped to t, and this p is also representing to the t. So it is okay, then we will move to the next element e. Whether e is in the string, no, then we will map e to the second last element in the string, that is l. Then we will check the last element r. It is not in the string, it is not in the dictionary, we have not mapped it yet. So what we will do, we will map this r to e. So this is how we are going to do. And similarly we are going to map these elements t to p, I to a, right? In opposite manner also we are doing. Is equal to yes element. And finally what we will do, if this for loop is completed and to any index, right, we are traversing through the string, and the false has not been executed to any element or any index, then what we will do, we will return true. Means if this for loop successfully completes, then the strings are isomorphic and we will return true. Let's try to run this code. Yeah, let's try to submit it. Yes, it is working nice, right? And it is much efficient. Okay.